Hey, chemistry students, Mr. Resentis here. I'm on chapter 9, and I strongly suggest that you read through the chapter starting on page 284. We're talking about balancing chemical equations. Now, we're going to follow the law of conservation of matter. That just means that on each side of the chemical equation, it has to be equal. So whatever this is, you're going to have the exact same number on that side. And so we're following that law. Now, in order to do this, there's some vocabulary you must know. You've got to know what a molecule is. If you don't know what a molecule is, you're going to be lost. You don't see the relationship. Please go back and research what a molecule is. I don't have time for it now. Also, you're going to need to understand what a coefficient is. If you don't know what a coefficient is, you won't understand that I'm changing the coefficient that changes the molecule. You see, if you don't know what a coefficient is, and you don't know what a molecule is, then you'll be lost. So there's certain bits of information that you have to have prior to coming to this. The last thing you need to know is what a subscript is. The subscripts are these little numbers that tell you how many elements there are. You don't change these, you only change the coefficients. Okay? Now, go back, research what a molecule is, understand what a coefficient is, understand what a subscript is, and I think it'll make it a lot easier. Right? We talked about these concepts, but that's I think is going to help you. All right, let's try a few, and maybe you can pick up the vocabulary as we go along. First thing, you've got to use a pencil. If you've got an ink pen, throw it away. It's useless. This is not an exact science. I'm going to change my answers because what we're going to do is we're going to try and balance them, and sometimes we get it wrong the first time, and that's okay. All right. Let's get cracking. We have a diatomic oxygen here, which is a gas. It's one of the Brinkelhoffs. And we've got aluminum, and then we have aluminum oxide. So we've got two aluminums. We have two aluminums and one on this side. Clearly not balanced. 3 oxygens on this side, 2 on this side. Clearly not balanced. So what I'm doing in my head is I'm thinking, what number can I put here to make this balanced? And I'm going to try 2. You heard me. Try. I might change that. That gives me 6 oxygens. So if I put a 3 here, 3 times 2 is 6. So I've got 6 oxygens on this side, I got 6 oxygens on that side, but that tells me I've got 4 aluminums. I only have 1 here, so I'm going to change that to 4. Now it's balanced. I have the same number on both sides. All right? Now I very well could have been wrong. I had to rub out and start over. All right? The second one here, you have to understand what a polyatomic ion is. If you don't understand what a polyatomic ion is, you're going to be lost here. Because the polyatomic ion acts as a unit, acts as one thing, acts as one element. And so it gets a subscript too. Right? It gets a subscript just as elements do. All right, so this one doesn't need one because there's only one. All right, this is sulfuric acid. And if you want to know, if you want to know about these acids, and you want to know their formula, you're going to have to go to page 249 in your textbook, and it lists the formula of these common acids. You'll need that. You'll need that whenever we write out in word form the equation, and then you need to know the chemical formula for an acid. All right, so we have iron oxide and the sulfuric acid and iron. Well, that's going to yield water and iron sulfide. So what we have is we have a you're going to have to start trying numbers to see what's going to come about. So we've got 3 of these sulfate polyatomic ions. So I'm gonna try and put 3 here. So if that gives me 3 of these. See, it acts as a unit. But when I do that, it gives me 6 of these. So I'm gonna go over here and I'm gonna try to put 3 here to give me 6. You see, I'm trying numbers. But when I do that, it gives me 3 oxygens, which is a very awkward number. But I have 3 oxygens here. All right? So the problem, though, let's see how we do here. So we have two irons, 3 oxygens, 4 hydrogens, and I'm sorry, not 4 hydrogens, 6 hydrogens, and 3 of the sulfate ions. So we have 3 of the sulfates, 2 of the irons, and so this appears to be balanced. All right. So let's try the next one. We have it's clearly a molecule of potassium chloride, potassium and chloride. That's another Brinkelhoff. That's another diatomic molecule. By itself, it wants to be with a partner. Now, a Brinkelhoff. These are all elements that, when they're alone, they're diatomic. All right. Oxygen is a diatomic. Chlorine is a diatomic. So these, you just have to know, are diatomic. So anyway, we have one that's balanced, but we have 2 of these, and I'm sorry, we have 2 of these and 1 here. So we're just going to have to change this to 2. That gives us 2, but it gives us two of the K's, and now we're balanced. All right. So let's try the next. Don't forget, this is gas, liquid. S is for solid. AQ is for aqueous. You'll see those. You'll see those again and again. All right. So let's see what we have here. All right. So we're just gonna have to try numbers and see how they work out. So we have there's really no. I guess I'm going to start with the most complicated and see if I could work from there. So this is ethane, and then we only have 1 on this side, right? So I'm going to try to put 2 here, although I really, in my heart, don't think it's going to work. If I put 2 here. Then we're going to start adding up these oxygens, aren't we? So we have oxygen equals 4, right? Plus 1 is 5. So we have 5 oxygens on this side, but clearly we only have 2 on that side. 5 is an odd number. We're never going to get 5, are we? We have to have whole numbers here in the coefficient. We can't have fractions. All right. So what I'm gonna do is I'm gonna change this. I'm gonna change this to 4, and it really is just a case of me just trying to see if I can get it. So here we have 4. We have C equals 4. H, we have 6, right? Oxygen appears to be the problem, but this one's all by itself. So I'm going to come back to that one. Let's balance out the carbon over here and the hydrogen, and worry about the oxygen late, because that one's all by itself. And hopefully it'll be an even number. All right, so the hydrogen, we need 6. So I'm going to change this to 3. So now we have the hydrogens equals 6. Now we have the carbons. The carbon equals and so we have carbon that equals, my apologies. See why pencil is so important? Carbon, we have 4 carbons and we have 6 hydrogens. All right. So what did that leave us in terms of oxygens? Well, we have 3 plus. See, there's 3 there. 3 plus 8. All right. All right, that's going to leave us with an odd number, isn't it? That's going to be 11. We can't work with that, can we? So what I'm going to try. What if I change this? Oh, I counted wrong. Hydrogen. This is 12. My apologies. I counted wrong. This is 12. So that's going to change this to 6. When that changes this to 6. When that changes this to 6, then that means I have 6 not 3 plus 8, right? So I have 8 plus 6. So that equals 14 oxygens, right? And then in order to get 14 oxygens over here, we have 7 and 7 is 14, right? So are we balanced? So we've got 6 plus 8 is 14. No, it's not. It's 12. My apologies. That didn't seem right. There we go. Okay, so we're finally balanced, and now you can see the role that the pencil plays, and you can see how we all struggle and try to plug in numbers, and it's not an exact science. All right. So we finally got it. We finally got that one balanced after a bit of a struggle. So you're gonna have to bear with me. All right. So in order to do the ones in words, these are a little bit more difficult because you have to take 2 steps. First thing you have to do is make the formula, right? So sodium phosphate. Now, in order to do sodium phosphate, you're going to need your list of polyatomic ions, aren't you? Because you're going to need to look up we're going to need to look up the formula for the phosphate. You'll also need the little oxidation numbers. So in order to do these, you'll need your periodic table with the oxidation numbers, and you'll need your polyatomic ion list. All right, so you've got to have your tables. Or if you want, you could also look in your book. Your book has the polyatomic ions on page. Where are those? Those you can see polyatomic ions on page 232. But if you don't have your table, these oxidation numbers, you'll have to find those as well. All right, so. Let's get cracking. Sodium phosphate. Sodium, if you look up sodium, the oxidation number of sodium is 1, and the phosphate, the oxidation number of a phosphate is -3. So that means we're going to need 3 of them. So Na3PO4B, and I just got that formula just from my table. All right, that's where I got the formula. So Na3PO4 plus calcium chloride. Well, calcium's got a oxidation number of +2. Chloride's got an oxidation number of -1. So that means I'm going to need 2 of them. Okay, and then that yields to form calcium phosphate and sodium chloride. Well, sodium chloride, that's easy enough. That's table salt. We know that one. Plus calcium phosphate. Well, calcium has an oxidation number of +2, and the phosphate we already looked up has an oxidation number of -3. So remember, you reverse those numbers, and so it's Ca3PO4. So, all right. So now what we need to do is we need to balance this, and as you can see, we have 3 sodiums and only 1 here. So I'm going to change this to 3 and see what happens and see what that leaves me. That leaves me with 3 chlorides, doesn't it? Well, in order to get 3 chlorides, well, that's gonna be awkward, isn't it? So I'm gonna get rid of that because that's an odd number, and I hate odd numbers. So I think I'm gonna change it to 6, and that'll give me 6 of them. Now I could work with 6 because there's 2 here, and I changed this to 3, right? So now I've got 6 here and 6 here. Okay, that's even better. All right, so now we have 6 sodiums, and 6 is easy to work with because all I have to do is put 2 here, right? And so now I've got 6 of these, but I've got 2 of these. Oh, good, I got 2 of these. And then calcium, I've got 3, so it's balanced. All right. See how it's not an exact science, and you got to plug numbers in and struggle a bit. Let's try this last one. Calcium hydroxide. We're gonna need to write the calcium hydroxide and we look up the oxidation numbers for calcium is +2, and hydroxide, and the hydroxide is minus. Just so we're going to need two of these in order to have an oxidation number that equals 0. Remember, this is +2 and this is minus. So in order to get oxidation numbers that equals 0, we're going to need two of these. That's some stuff that you remember. And then we have phosphoric acid. Now, phosphoric acid, what you're going to have to do for that one is you're going to have to just refer to page 200, see page 249, or get a table that has these common acids on it. All right, so these are just these common acids. We just know that phosphoric acid's formula by looking at the table. And let me just take a peek here. Is H3PO4. All right. Now that I have phosphoric acid and then calcium phosphate. Well, calcium and then our phosphate. We know. We see the phosphate group there, but I don't know that our oxidation numbers equal 0. So just let me get the subscripts quickly. Calcium's got +2. Phosphate we already looked up has got -3. So 2 and 3. So what we do, so for calcium. So for calcium phosphate, it just rang a bell, and so it happens to be up here, and so I was like, wait a minute, I just wrote that, didn't I? So calcium phosphate's in both those, and water's H is easy enough. We don't even need to look those up, do we? All right, so let's take a look, see if we could balance these. Calcium is got a problem here, doesn't it? So I'm going to put 3 here to balance that, and that makes oh no, I'm sorry, I no, yeah, wait a minute, I'm PO4 2 plus H2O, calcium. Yeah, the hydroxide. Okay, my apologies. Yeah, we have one of them. We have one of them here. Okay, so we have 3 of these, and then the hydroxides we have 2 hydrogens, but 2 times 3 is 6. So we're going to need 3 here, and then that's going to give us 3 times. It's going to give us 6. That's not going to be balanced, is it? Calcium is balanced. The hydrogen is. We're going to need. Goodness, we're going to need to change our hydrogens. Phosphates are okay. Calciums are balanced. The biggest problem here is 3 times. So we've got 3 oxygens and I'm sorry, 6 oxygens and 6 hydrogens. So, but we only have 2. We only have 3 on this side, right? So I'm going to have to change this, aren't I, to 6. That'll give me 6 oxygens. 6 oxygens, but 12 hydrogens, and then 2 PO4s, right? And then 3 calciums. So on this side, I've got my 2 PO4s. I've got 2 times 3 is 6 hydrogens, and so I've got that's a 6 hydrogens, but I've got 6 here too, don't I? So 6 hydrogens here, and I've got 6 oxygens here. So 3 times 2, 6 oxygens, and I've got 3. So That one finally did get balanced, but as you can see, it does take some work. All right, and we all have to struggle with them, and make sure you use pencil